Scopes in C# determine where variables can be accessed and how long they exist. They help us organize and manage variables effectively within our program. Knowing how scopes work is important for writing clean, efficient, and bug-free code. In this lecture, we'll explore the different types of scopes in C#, their rules, and practical examples. Okay, let's dive into the C# scopes and get started. Hello everyone, welcome again. Okay, first things first, what is scope? A scope refers to where a variable can be accessed in a program. In C#, variables can be defined in a class, method, or code block like loops and if statements. C# has three scope categories: class level scope, method level scope, and block level scope. Variables declared inside the class but outside any method have class level scope. They are called fields or class members and can be accessed by methods or anywhere within the class. Variables declared inside the method have method level scope. They are not accessible outside the method but can be accessed within the nested code blocks inside the method. These variables are called local variables. Variables declared inside the block, like for loops or if statements, have block level scope. They are limited to the body of the statement in which they are declared. A variable declared inside the block is not visible outside of the block body. These variables are known as loop variables or statement variables. Okay, a class level variable is accessible to methods and all blocks like loops, while a method level variable is accessible to blocks. To better understand scopes, let's continue the discussion with an example. Let's consider this code. Note that this code is just an example and doesn't perform any special tasks. Okay, as mentioned earlier, when we execute a C# application, the CLR invokes the main method within the program class. Additionally, each time a method is called, a new stack frame is created to manage its execution. Stack frames are important for handling method calls and memory in C#. A stack frame contains information about a method call, such as the method's parameters, local variables, and return address. In this case, inside the stack frame of the main method, two local variables named A and B are allocated memory on the stack. These variables have method level scope, which means that we cannot access them from outside the method. Next, we create an instance of the class using the new keyword and call its constructor. The class object is stored in the heap, while a reference to it is stored in the stack frame of the main method. This class has two fields, number1 and result. Since we haven't given them specific values, they take the default value of 0. These two variables can be accessed in all methods and blocks of the class, because they have class level scope. As you can see, inside the constructor, we can simply access the number1 field. Constructors are treated like methods, so when this constructor is called, a new stack frame is created to manage the class-related information. This constructor has a parameter named number, and when we call the constructor, we pass the value of the A variable as an argument. Since int is a value type, number receives a copy of the value stored in A. Inside the class stack frame, the constructor parameter is treated as a local variable. So here, we have a local variable called number. This variable has method level scope and cannot be accessed outside of the constructor scope. Then, inside the constructor, the value of number is assigned to the number1 field. As a result, the value of number1 is updated within the heap. When a method finishes executing, its associated stack frame is removed, and the memory allocated to its local variables is automatically released. In this case, the class stack frame is destroyed, but the class object remains in the heap. We can still access its members within the main method, because the class1 variable which stores in the object's address has method level scope. Next, we call method A of the class, which creates a new stack frame for method A. Inside the method A stack frame, 3 local variables named number2, result, and another result are stored in the stack. Within method A, we make 2 method calls, method B and method C. Each call creates a new stack frame for the respective methods. First, we call method B, which creates another stack frame. This stack frame has 2 local variables named number2 and result. In method B, we calculate the sum of number1 and number2. When the program encounters number1, it first looks for the variable in the stack frame of method B. If it's not found there, it looks for the variable in the object where the method is defined and finds number1 there. After that, we return the value of result in the next statement. Then, the stack frame of method B is destroyed. Based on the return address in the stack frame, the program continues execution at the location of the method call. The return address in a C# stack frame is a memory location that holds the address of the instruction where the program should continue after the current method finishes executing. It's like a bookmark indicating where the program should go next in its execution flow. Now we call method C, creating another stack frame. This stack frame has 2 local variables named number2 and result. Inside the method, we set the result variable to 0. When the if statement is executed, memory space is created within the method C stack frame. When the program encounters the number1 variable, it first looks for it within the space reserved for this block. If it's not found there, it searches for the number1 variable in the stack frame and then in the object where the method is defined, finding it in the object. The same process happens for the number2 variable, which is found in the stack frame. Then, we store the result of dividing these 2 numbers in the divide variable. This variable is placed in the space reserved for the if block within the stack frame. Therefore, the divide variable has block level scope. As you can see, when a variable like number1 has class level scope, it can be accessed in all methods and blocks of the class. Similarly, when a variable like number2 has method level scope, it can only be accessed within the method and its blocks. And when a variable like divide has block level scope, it can only be accessed within that specific block. Finally, method C returns the value of the divide variable. Based on the return address in the stack frame, the program continues execution at the location of the method call. Then, the execution of the method ends, and its stack frame is destroyed. Next, method A ends, and its stack frame is also destroyed. After that, based on the return address, the program returns to the location where method A was called. Finally, the main method ends, and its stack frame is also destroyed. Okay, done. See you soon.